Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No libraries, no engine, it's just us. And we are going through all every little last piece that makes up a game, from the thing that puts the pixels on the screen all the way up to the artificial intelligence that runs the enemies and that sort of stuff. Basically, the entire gamut. And it's been a lot of fun doing it so far. I'm having a good time. I hope everyone else is having a good time because honestly, we just show no signs of stopping. We're just barreling through. And speaking of barreling through, we are in the middle of doing some collision detection updates. And specifically what we've been working on recently is extending our notion of what the world is and how you move around it into 3 dimensions, so that basically we can have a 2D game, which is our goal, but that it handles 3D in a rich way so that anything that we want to do in the game world that needs a little more concept of height to it will be able to work well and not have to have a ton of hacks piled on it. So we're basically kind of going through that, sort of putting it in and perhaps doing those hacks early now so that we can see what they look like and then start to pull them apart and go, okay, how can we make this more general, more complete, easier to use for the code that will have to use it that's going to be layered on top of it, and really kind of nail that down. So where we've come to is we're actually in a pretty good spot with that stuff, but we have one major concern left in terms of our representation of the world that we want to iron out, and that's what we're going to be starting on tonight. And that is that we don't currently have any real philosophy behind how we're representing where the ground is. In a straightforward 2D game that has absolutely no interesting depth effects in it whatsoever, there really isn't any notion of where the ground is. You're just moving sprites around on a plane, and you never really think about the concept that there's this depth to it. But we want a game that is more advanced than that, and we want to be able to have layers on top of layers in the world. So we can have multi-story rooms or towers or ledges, that sort of thing. And we want those things to work intelligently. And furthermore, we want to be able to have gameplay and rendering that work seamlessly across these. So if you want to be fighting someone on a stairwell, we want that to work. If you're going to be fighting someone from a ledge that's 2 stories high, like a giant monster, we want that to work. And we want you to know that you're hitting him like up in his head, as opposed to if you were down there and you're hitting him at his feet if you were on the lower level or something, right? We want all that stuff to be represented sort of in a nice, unified, clean way. And we've done that for most of the things, but what we don't have now is just how do we know what sort of the walkable area is when there's stuff on, if we're going to have these multiple layers, how do we know what's walkable? And there's a number of ways we can solve that problem. I'm not sure what the best one is, so what we're going to start doing today is drilling into that and figuring out what we need to do to tackle that problem. Okay, before I get started, if you have been following along at home, if you've pre-ordered the game on handmadehero.org, you should have gotten a link in your email, and that link has the source code in it. If you want to follow along at home, unpack the source code for day 78 from the source code zip file, and that is what we'll be starting with here on day 79. So if you want to follow along with me, that's the way to do it. All right, so let's probably, I think we almost don't even need to fire up the editor yet. I'll do it anyway, but really this is going to be a little bit of a Blackboard discussion at the outset because we need to sort of decide what it is we're doing here. I'll briefly check our to-do list just to make sure there wasn't something I wanted to do before talking about any of this, but I don't really think that there was. I think for the most part, yeah, we basically got, we could go do this, the ground collision loop stuff, but I think maybe doing the ground, getting a handle on the ground first before we try to solidify this is actually going to be the right order to do things in, because I feel like getting our ground concept in the collision loop straightened out would be helped if we had a notion of exactly how we want to handle the ground in general, since those two things are kind of interrelated, and this one's kind of the more sort of systemic picture. So let's talk about this for a second. I was thinking about this a little bit today. I'm not really sure why. Just like I said, a lot of times stuff just pops into my head. That's stuff I've been working on. So let's see here. Where are we? We're day 79, right? All right. So here on day 79, let's talk about the ground. The ground. The ground round. It's the ground that's around us. I don't know if you guys had. Do you ever have that restaurant? It was called the Ground Round. I don't even know if they exist anymore. They probably don't. They were a Massachusetts thing. I think they existed outside of Massachusetts. I think they were, at least East Coast or at least New England, but I don't really know. Anyway, don't think it was a particularly good restaurant. Probably. I don't know. I don't even know if I ever ate there. But what can we say? I'm sorry I even wrote the ground. It's bringing up things that just aren't relevant. Anyway, let me start by talking about the thing that I thought of today. It's a little bit of game history. And I felt like it had something to say about how we might handle our ground problem. And that is sort of the Quake versus Unreal model, right? Now, I'm not talking about the game Quake versus the game Unreal, which is what it would be if this were a title in a game magazine where they're going to be like, X is awesomer than Y because of some reason. I'm actually talking about how they constructed their worlds. And if you remember, well, probably a lot of you maybe were too young to remember, but the way that these games used to work is they used to use something called constructive solid geometry, right? So constructive solid geometry is this notion that we sort of build the world out of these things. They called them brushes oftentimes, which is a really bad name, but really what they are is polytopes, some kind of shape in 3D space. Like maybe I've got something that's kind of like a little thing that I'm gonna create here, and it's some polytope or whatever, right? Maybe it's got a little hidden line surface remover there. And what I do is I stamp this down and I say whether this is an empty region that I'm carving out or whether it's a filled region that I'm filling in. And so the way that you created the world is you might say, okay, I want to make a room that has some pillars in it, and I have one of these brushes, right, that's a thing that looks like this or whatever, and that's my really lousy column, but I'm going to stamp that around in a couple different places to make a room that has 3 pillars in it or whatever, right? And it's called constructive solid geometry because there actually was a notion of inside and outside of these things. They were closed, bounded solids that actually existed as solid geometry, unlike in modern games where oftentimes there's sort of something that's typically called a polygon soup, right? Polygon soup is when you just have some bunch of triangles that an artist made that doesn't necessarily have any notion of inside and outside. There could be holes in it, there could be cracks in it, there could be just fins sticking off it, like what a tree might have for leaves, things that don't represent a bounded solid. And so this constructed solid geometry was sort of a more robust definition of a world, if you will, than what we often use today in the polygon soup way, because this was actually creating a world that always had a consistent notion of what was solid and what was inside and outside of the world, what was empty space and what was filled space, right? And so both of these games actually used the constructive solid geometry approach. Obviously, it was pioneered by John Carmack in the game industry space, and people followed suit, including the folks who made Unreal. But they picked different paradigms when they actually made their level editors. So the Quake's way of doing things was to start filled and carve, right? So the definition of the world was that the entire world is a giant filled block, basically. Everywhere is solid. And then the way that you make a world is you start carving out. So if you imagine, if we did this in 2D, I've just got this giant solid block, almost like I'm, some kind of a sculptor. And the first thing I do is start to carve out a room. So maybe I carve out a room that I'm going to create here. And then, I go ahead and I carve out another room, right? And then maybe even a hallway in between those rooms. And what I've got now is I've got a definition of where is empty space because it's everywhere that I've carved out. And anywhere that I haven't carved out is solid, right? And it's worth noting that there was nothing that said that you always had to carve out. You could then add a brush in that was designed to fill and refill in back some area. So you could always add and subtract, but you started with everything being solid. Unreal, on the other hand, was the opposite. Unreal started empty and filled, right? And so the way that they would do things is they would say, well, the universe is a giant open space. And so if you wanted to make a room, what you would actually do is you'd actually place wall brushes around the room that you were trying to make, and they would fill it in. So now you would never get this sort of a thing. You'd get this sort of thing where there's empty space all throughout all of here, and there's empty space on the inside, and then there's just a solid boundary that encases things, right? And these are very different ways of doing it. Now, this was a very long time ago, and I'm quite sure that the Unreal Engine of today bears no resemblance to this at all. I'm sure that people don't even use constructive solid geometry anymore. I'm not sure when that went away, but it was probably sometime in 2005. Most things that were using constructive solid geometry started to stop, or had stopped, I should say. But from 1995's development cycles through 2000 and somethings, this was still an active way that things were done. And even in some Quake legacy engines like Half-Life, the concept that there was constructed solid geometry underlying the game actually persisted for quite some time. I strongly suspect that Half-Life 2 may even have shipped still with all of that kind of in the underpinnings of it, and it wasn't till later that they actually finally got rid of like the last vestiges of this concept and moved over to more of a polygon soup based representation. But so given that fact, I want to talk about the difference between these two things, right? So I want to talk about the difference between this model, where the thing that I say is that we have emptiness, and this model, which is to say that I specify the filled part and there's emptiness on the inside and the outside. So, and we'll say this is the Unreal way and this is the Quake way, right? So what I remember at the time being an important reason why I liked this method better, the Quake method, is because it meant you could never accidentally fall out of the world, right? The world is completely solid. And so anywhere that you could move through had to be something that someone actually carved out at some point, right? Whereas in the Unreal method, it was actually pretty easy for some level designer to maybe not quite realize what had happened, and when they were making stuff, they made something that looked like this, right? And there really was a little hole here that was just big enough for a player jumping at the right angle at the right time or whatever to fit through and end up outside the world, where they would fall infinitely forever, never really hitting anything until maybe they hit some, I don't know if Unreal had some kind of a catch-all kind of thing that would happen, but this is, they would be outside the world. But you could never get outside the world in Quake because there was nothing outside the world. The world was actually solid. So the only things that you could move through were things that some level designer had actually carved out. And again, this is the very early days. So all of this stuff may have changed with, say, Quake 2, Unreal 2, right? Like, so I'm talking about early, like the original versions of the level editors of these two things. And so this may be an important lesson for us to take away from gaming history and say, well, as I've said multiple times on the stream, I am hesitant to make something where we specify where the ground is. And the reason that I was hesitant to that is because most of the time there is ground, and a lot of the stuff that we need to specify is just where ground isn't, right? And so that's the route that I was kind of taking in my head because I thought it would be more efficient or whatever. But Efficiency is an interesting concern, but I tend to rank them more this way. I tend to want this first and then this second in terms of playability concerns. Like if there's a chance that the player could encounter a game-breaking bug, I'm probably not going to do the efficient thing that might introduce that bug or that makes me concerned that I might have that bug. I'm going to prioritize robustness first and accept a less performant game in exchange for not having that game-breaking bug. Now, again, like, games are extraordinarily complicated. Will we be able to ship Handmade Hero with no game-breaking bugs? Probably not. You know, has anyone ever even done that? I don't know. But that doesn't mean we don't try, right? Like, even though we're doing something very complicated, I feel like it still helps to prioritize, because we'll have, at the very least, if we have a mindset for it, we'll at least have less, and the chance that a player encounters a serious bug that ruins their play session will be much less. And so that matters a lot to me, because I really don't like players to have to go through that. And I realize this is actually fairly rare of a prioritization. I don't see a lot of game industry programming focusing on that, and so I don't pretend to speak for the industry at large in that way, but that's just my personal opinion. And so what that means for me is that maybe I should rethink the way that I was thinking about the ground, and that I really don't want to do the most efficient thing there, and instead want to focus on something that will be as robust as possible and minimize the chances that the player can ever find themselves in an unwanted circumstance, such as getting outside of the world, like this case. So what that led me to consider, and what I'm going to propose now is perhaps what we could try for ground, is instead of thinking of ground, or floors even, because someone yesterday had suggested maybe if the ground was like a solid, you know, like it was like had depth instead of just being a plane, right? What I'm thinking is maybe we turn this around a little bit, and maybe we say that we're not going to talk about ground, and we're not going to talk about floors. What we're going to talk about is rooms. So what we will do is we will place regions in 3D space that we consider to be walkable, space you can move around in. So, you know, it's not solid, it's empty. We're specifying the empty space, and the player stands on the empty space. If they would have fallen through into non-empty space, that is where the ground is. So the ground is just somewhere that if you were to go below it, you would no longer be inside one of these empty space regions. And so what our world would look like at that point is a series of overlapping empty spaces which form the continuous area that the player can move through. And they are always also subject to collision with entities like our trees or other things like that. But they can never, the collision detection will literally never allow them to be placed in any circumstance where they would be outside of one of these regions. It will literally be impossible. So like at the end of the time step, it is just going to be a hard guarantee in our collision loop that you are not allowed to be placed in a location that would be outside it. And if for some reason we detect that that's true, we disallow the move. So we won't allow you to actually do your move if it would have put you outside as a fail-safe. So even if for some reason the collision messes up, would have put you outside one of these things, we just say that's not allowed, right? And so our definition for ground at that point is going to be something along the lines of, you know, if this is a side view and we have two overlapping things here, and, you know, we do something like this, then that's okay. If we do something like this, and, you know, I don't know, maybe we'll collision detect against it too, but I'm not sure if we want to do that or not. We may not need to, because collision detection may just be for entities, who knows. But something like this would not be, because this puts you outside it, and that would project you back up kind of into the place where you're allowed to actually stand. And so I think I'm leaning towards doing this method, and the reason that I'm leaning towards this is because I think it provides us an extra level of sort of fail-safeness. I don't know how you want to say it. It provides us an extra layer of robustness, let's say, where we're going to we're going to have some insulation that will catch if we forgot to put a tree in some place and the player can walk outside of it. There's still at least an invisible wall that will prevent them from walking out and falling into nowhere or walking out into nothingness. It wouldn't be as good as if we always obviously didn't have that problem, but it would at least give us some notion of sort of containment. And we could also do something where instead of those walls being invisible, we could do something where if you are outside of that region, we draw in some placeholder pattern that's like trees or rocks or whatever, so that it even looks kind of okay in the case where there's a problem, right? And so I feel like this is a pretty good solution. I think it's probably something that I'd like to pursue first. And so what that means is that our definition of ground is going to just be a very simple, very basic game-style probe where at any point we will simply look downwards from where that point is, and we will see where the first place is where you would pass out of one of these regions into space that was not considered empty, right? So the first place that you would pass out of one of these regions and not into another region, right? And so it's a little bit tricky. I haven't thought through exactly how to do that part of it yet, and the reason is it's very easy to do that kind of a check for just, for a box, whether we're leaving it or staying in it. It's exactly the same as what we did in the collision detection, right? But the thing that's a little more confusing is that you're allowed to leave a face of this box as long as there's some other box that encloses this other area, right? And so it's a little confusing because I guess what we need to do is every time, I'm just thinking this through, if you imagine we have these boxes, we just see which box you are inside, and then when we do our raycast, we're raycasting against that box. When you leave that box, we would then do another query to see what box you would be inside, right? And if there isn't one, then that's a collision point and you would have to stop there. If there is one, then we simply change to doing casting against that box. Now, the reason why I say it's not immediately, it's not necessarily 100% clear is because you can imagine some relatively complicated scenarios. Like, let's say I have two boxes, right? And I'm trying to get outside of them. Well, if I constantly did this query, if these two ended right on that line, I might oscillate back and forth between them and never escape out of it, right? I might be like, oh, collide against this box. Okay, I'm leaving this box. What box am I in? Like this is box A and this is box B. Oh, I'm in box A. I collide against the wall of box A. I leave that wall. I find what new box I'm in. It says I'm in box B. I'm in box B. I do the collide. It collides against this wall. I leave that wall. It says I'm now in box A, and I just go back and forth and back and forth and back and forth, right? And that is exactly the kind of thing that happens with kind of the fiddly math of collision detection if you're not careful. And so I do think that maybe we will have to kind of think it through a little bit to see what is the most elegant way we can reduce that sort of process to something that doesn't have a lot of nasty failure cases like that. Obviously, we can cap the iteration count very trivially and make it so that we don't have like an infinite loop bug or anything like that. But we may have a bug where there was actually another box and you could have gotten further through it and you simply couldn't. One way, even as I draw it, I'm kind of thinking about what it would be. And I'm kind of thinking maybe, here's the thought bubble. Maybe the answer is, pick the box with the furthest dot. And what I mean by that is, let's say I'm exiting this and I want to pick the new box that I'm going to travel along. What I could do is say, well, what if I took this vector, right, that I'm moving along, and I said, which of these boxes has a point whose dot product is the largest along the direction of the vector that I'm traveling. Because that would eliminate these kinds of vectors there, right? Because they're never going to be further than, say, this guy, right? And I don't know, that has some promise, right? That's the dot product of this on this is going to be like here. But of course, the dot product on here is going to be here, so it's a little bit hard to say. The dot product may not be the best choice for us to think about this. I feel like there should be some kind of measure. I mean, I guess what we could do is, it's more expensive, but we could just run the intersection test. So basically what we would do is we do an intersection, we find that we're leaving a region. So then we do an intersection test on all of the boxes that we now are inside and see which one of those was actually furthest, right? That seems pretty straightforward. I don't know how expensive it'll be, but that seems pretty reasonable. So it's something like, you know, for each box we're inside, right? Pick furthest intersection. And so in some sense, this is the exact opposite of our current collision loop, right? Our current collision loop is pick the earliest collision, because that's trying to stop you from moving. And this is the opposite. This is trying to allow us to move. And so now that I think about it, we actually could basically just perform that constructed solid geometry in the collision detector, right? We have some number of boxes. Yeah. See if you're with me on this. We have some number of boxes that are marked as in boxes, right? And so these are in boxes. We have some number of boxes that are out boxes, right? And these are our entities that we're colliding with. When our collision detector goes to do its collision detection, could we not simply say that we have two t's values, essentially, right? Or not even two t values. We just have one t value for the intersection, right? No, sorry. We have two t values. We have our t for in boxes and our t for out boxes, right? And the t for in boxes and the t for out boxes are both, I guess what I would say is the t for in boxes, they operate in exactly the opposite fashion. For in boxes, we set the t to be right at 0. So the t for in boxes is 0 at the start. The t for out boxes, right, is 1 at the start. It's the furthest we could move. Then for each of the things that we are checking against, we say, is it an in box or is it an out box? If it's an out box, we do what we were doing before. We do our collision detection, we see whether the collision with it happens at a t that is less than the one that we have, and if it is, we accept that as the new t for out boxes. So this is starting at 1 and it's moving towards 0 with each collision, right? It's getting closer and closer to 0 with each collision, and the closest thing that we hit, we know that that is as far as we could go before we hit something. The t for in boxes is the opposite. It's going to go ahead and say for every box that we are inside, right? See how far we could go. What's the first intersection with one of those boxes' walls? And that moves toward 1, right? So that gets higher and higher. So the furthest out we could go, that's the one we pick. We then have these two t values and we say whichever one is minimum, right? So we take the smaller of the two. That will give us our collision. It will give us the collision that tells us how far we went, right? And it seems to me, I could be wrong about this, but it seems to me that is essentially a complete solution, perhaps for our ground problem as well. I don't actually know if that's true. I'd have to think about that. I mean, essentially, ground could just be thought of as after you do your lateral movement, we just move you down however much, so, you move, this is a side view again, you move sideways, and then after you're done moving sideways, we move you down as far as you can go. Collision detection as well. So we basically have 2 collision steps, moving you laterally and then moving you sort of down. I don't know if we would want to try to do something fancier where we tried to do movement in sort of a more sensible fashion. This is where collision detection gets kind of wonky. Again, I tried to solve this stuff in the witness using a much more odd scheme than what we're working with here. I'm trying to do a more traditional collision detection scheme here because I feel like this game will not require such heavy artillery, but that does come with the fact that certain things are a bit odd. And so, for example, movement on ramps, when you're coming up to the ramp, what happens when you're kind of coming up the ramp here? When do we kind of re-put you back down on that ramp, right? And so, I don't know. I don't know exactly how we want to handle that. And I don't know exactly how we want to look at some of these things. But for the most part, since almost all of our motion happens laterally in that way, we could pretty easily just say that is how we're going to do things. Now, we have another question to answer, and this is a gameplay question. So I'm feeling relatively good about this. This seems pretty solid. Let's see, we're probably taking a lot of time here. We're a half hour in, and all we've done is talk. But sometimes you got to talk it out. You got to talk it out. So we have one other question to answer, and that is this one. What happens when you step off a ledge, right? So if I'm here and I walk off here, do I fall down or do I stop, right? And I don't know the answer to that question. It seems like we might want to let you fall down. Because if this actually were constructed, we'll think about the case where this would happen, right? We're not talking about something where we've constructed a room and then we have, some bottomless pit in it, right? Because if that were the case, we could just mark this. This wouldn't be carved out as empty space. We'd mark this as actually a collider so that you can't walk into the bottomless pit, right? So we're not really talking about that case. We're talking about a different case. We're talking about the case where you can see, a Monstar down here or whatever, and you're up here. And the question is, do we let you hop down there? And I mean, it seems like the natural thing to do. And if we didn't want you to, it seems silly to complicate the collision detector by making it have to think about this. So we could just put a synthetic collider over the top of it that was raised up, and so that you would just hit it, So I feel like the answer is, for this, don't care, right? We don't care about this. We're not going to handle that case. We're just going to let you fall, and you fall down to whatever the ground is that's underneath you always, right? That seems like a pretty reasonable thing. So I guess what we would say is, basically, let's do this. Let's do exactly this. And so we'll have it so that you can, let's do exactly this. We're going to do this exact algorithm that I described, and we're going to say that afterwards we do a probe downward to place you on whatever the first thing is that you would have hit. How does that sound? Is everyone down with that? I don't know if everyone's down with that or not. It takes too long for me to wait as well to see whether people are down with it, because of course there's the Twitch lag and so on, so I have to kind of wait and see, what's going on? So I don't know. But it seems to me like that is a sensible way to go. So I think that's what I will do. I think that is what's going to happen. So let's see. Let us see. I am going to start by making those room cutouts because that seems like the most sensible thing to do. We need to make a room in order to walk through it. So we're going to call this an entity type room, maybe? Or space? Let's call it space, because that's what it is. It's space. So we have an entity type space, and that's kind of going to be a very special type of entity. It's what's going to carve out pretty much all of our world there. So that's kind of interesting. And I guess one of the nice things is we've already kind of introduced this notion that we have a sort of complex collision volume, so we can actually have a single space entity can actually be concave as well. It can sort of be shaped however we want. So that's kind of interesting to some degree. I don't know how much we'll take advantage of that necessarily, but we'll see. So I'm going to go ahead and give us the ability to create these space entities. And then I guess I'll just render them kind of uglily. I don't know how to say ugly in that way. Ugly. I want to say uglily. And so we can kind of see that we, in fact, do have them in there and that they are really in the place we think they are, let's say. So if I go in here and copy one of these rectangle calls, right, I'm just doing basically the same stuff that we did with the, stairwell where we were drawing those rectangles. I'm going to say that this is our entity type space. We're going to go ahead and push some rectangles on that define where this guy actually is. And so what I'll probably do is say for each of his collision bounds, right, each of the things that are in his, whatever the collision group, right, sort of for each volume count, I'm going to draw that volume. Okay, so to do that, I'm going to say loop over these guys, right, pretty basic here. This is the entity collision volume count. Wow, not a good tab completion day, huh? You know what? I'm feeling constrained. I'm feeling constrained here, people. I don't like to be constrained. There we go. Let's get this going. All right. So I'm gonna go ahead and pull out those volumes, one at a time, and we are going to draw them one at a time. Because computers pretty much have to do one thing. Some of you can do multiple things in parallel, but each one of those things is still doing it one at a time. Very, very single focus. These computers are. So I want to take this volume and I want to figure out where it is. I feel like one thing that would be nice, and I don't know if this is going to be. I feel like this has happened enough times. It's going to go ahead and do it. Instead of accessing them this way, I want to do something where I can say get camera or get region space volume, where I just say, look, here's a collision, here's a volume index for this entity, right? Just give me back what it would be in region space, so I don't have to do the thing where I add the offset and whatever, right? Just give it back to me, and so I can use it directly. So that way its offset P is just its actual position, and I don't have to deal with offsetting it by the entity thing, or if the entity had some scaling, it could scale the dimension for me too, or whatever else, right? So I'm going to do that just to give myself a little more leeway. So if I do that, right, oh, you know what though? I picked a really bad time to introduce that, because it turns out I don't even have to do that, because this will do that movement for me. Ugh, my bad. Because these are already in entity space. This push rect actually takes in the entity space. Well, so much for that. I thought I was going to I was trying to be helpful, you know. Shows you what you get. You try to be helpful, and then it turns out your help is not wanted, right? your help is just not wanted. And you know, you feel bad about it afterwards, but that's just how it goes. So if I go ahead here and pass the volume dimensions, I can pass just the x and y of that. We don't care about the z so much right now. And then if I pass that offset as well, again, don't really care about the z at the moment. I just want to see the rectangle at the location of the entity. I feel like that should be sufficient. This is going to be a pointer now because I didn't do the little fancy thing that I was going to do that would have been cool. And then it all came crashing down. So that's offset P. And there's our program. So now what we need to do is actually make one of these entities. So when we're actually creating rooms, we got to create some empty space for our rooms. And so really that's pretty straightforward. All we have to do is just make a series of these that overlap. We don't even have to be particularly conscientious about it right now because that's really something more for when we do for world gen, you know, when we actually are going to start placing those things. We can think a little bit more about it. But so if we go ahead in here and say, all right, we've got tile X, tile Y, that's going to loop over this. Before we do that for a given screen, right, we should go ahead and add this empty space. So what I want to do is I want to, instead of add wall, right, I want to be able to do add space, where I can add in some space that is, I don't know how I want to specify this. I guess I want to specify an abs tile X, abs tile Y, like range, basically, right? So I want to do something like this, where I'm going to go from the min and the max, you know, between the min and the max kind of a thing. So abs tile Z, I think, is just, yeah, so it's where we're at there. So it'd be something like this. We want to go from tile X, tile Y, abs tile Z, excuse me, need a little more tea. I want to be able to go from this point, basically, to, I guess, how much empty space do we actually want? So for width and height, I guess we would just, maybe we just specify the corner, and then we specify the width and height. Because the width and height is going to be like that, tile depth in meters, right? So we probably have something like this. Where we're going to say, yeah, here's that width and height. Now, of course, this would be passing that in as meters, which we don't really want. So maybe I'm going to just, I'll say that. It's one of them high or something like that. That seems reasonable-ish. Although now that I think about it, we probably don't quite want it to go that high, right? Because we want some space that's solid that you're not allowed to move through, and that's the floor, right? So there's, you know, essentially the floor is not infinitely thin. We might as well give it some thickness because we can. So if I was to do that, I guess I would say, you know, let's say that it's, you know, 9F tall, and that'll be in tiles, right? And so because these are all in tiles, and this is in tiles as well, right? So yeah, so let's take a look at that, and I'll pass these in so that you're allowed to pass in fractional tile widths if you want. I don't know, not the best way to specify this, I admit that, but again, I don't really want to spend a lot of time on the world gen stuff now, because that's going to be a whole big thing that we do that we'll kind of get into that'll be a lot better than what we're doing now, and so I don't really want to spend a lot of time thinking about it right now because it's just not that productive to do so. So all right. So let's go ahead and put that in here. We'll make an add space that does exactly what we just said, and all this is going to do is just carve out a region of the room, a region of the world, and say you can walk here, and that's going to be sort of our abs tile X, our abs tile Y, our abs tile Z. So this, I guess we should say this is the min tile X, min tile Y, and min tile Z, like so. And I don't really know, to be honest with you. I kind of feel like we almost want that to be a little more. Yeah, I don't know. I'm not loving this. I'll be honest with you. I'm not loving this way of specifying this. It's given me the creeps. It's true, but you know, what are you gonna do? So width, or I should say dim x. Or tile dim x, I guess. tile count X. Maybe that's a good one. Tile count Y. Tile count Z. Like so. And so, yeah, the reason I don't love this is because we're typically using this chunk position from tile position that's used to add entities into the world like that, and we presumably would still want to do that, but then we just want the size to be based on these two things. So now we got a situation where we have to think about that, and that's kind of annoying. So I don't know, like maybe let's, for now, again, to keep things simple, maybe we'll do it the other way. We'll say this is going to be like a center tile point, right? Like this. And then this is going to be sort of more like this. And maybe that's this way. Dim x, dim y. And so it'll go from that center out. And maybe that'll just be a little bit easier for us to specify. Again, for now, we're going to have to think through much later on how we want to actually do this generation. When we kind of have the world generating, we'll have an idea of what will be easier for us to do and how we want to do it. All right, so I suppose in this case we can actually reuse our room collision as well. Like basically every room could use the same collision, and that would be kind of nice. So we could just call that the standard room collision. I hadn't thought about that. That would actually mean that when we add space, we don't have to do any of this stuff. We can just have kind of the standard, a few brushes, and they just get reused, which is kind of interesting. Hadn't considered it. I guess that is kind of nice, actually. Yeah, I like that. So let's go ahead and say that this actually, maybe this actually just works literally exactly the same way. Everything can just work. There doesn't have to be anything particularly special going on here. We'll do it exactly the same way that we were doing it before. We'll get the absolute position. We'll add the space to it, and we will use that standard room collision. And so we'll call this add standard room. Yeah, I had not considered that. That's kind of interesting. And so we'll add a flag here, and the flag will be something like empty space, I guess, right? Or like traversable. I don't know, something like that. Traversable. Is that an I, or how do you spell traversable? Traversable. Traverse-able, of course, it's an A-B-L. All right. Traversable. So I had it right. Then that's it. That would just work, I think. So then what we need to do is we need to add that traversable flag, and that'll be a thing that we use when we're in the collision detector. That's actually going to be in sim region, obviously. Let's see here. Z supported, and then we have traversable. Okay. These are going to definitely have to be cleaned up a little bit because we've got more stuff now than we probably need. We've kind of unwound some of our hacks. Like Z supported probably won't have to happen anymore, right? That'll probably just go away. And so, you know, we'll probably be able to do some stuff like collides. Probably won't need to be there either because now entities have a collision volume. You could just set their volume count to 0 and they won't collide with anything. So, you know, to do Casey collides and Z supported, oops, collides and Z supported probably can be removed now soon, I would think. So, now that we said this thing is traversal, what we need to do is make that standard room collision, right? Because that's not there yet. And we also have to do, in here, we're going to have to change the way we're doing this a little bit. We would not be passing this anymore. We'd be passing that center. So what that's going to be is that is going to be this right here, tiles per width, tiles per height. It's going to basically be, we want the screen X plus a half, right? We want to basically make, we want to basically be the center of the room is where this empty space actually is, right? So we want to go to the corner and then a half more, if that makes sense. So let's do that and leave that as our room definition, and then we just need to make that standard room be correct. And so this is standard room. We know we've got a standard room collision here. And then when we do our wall collision, we just want to do that same thing again, standard room. And that's going to be the tile depth in meters times some smaller amount, right? We said 9, something like that was what it was going to be. And then the tile side in meters, it was going to be our weird kind of notion here, our sort of crazy constants, tiles per width and tiles per height. It's going to be that many wide and high, right? Something like that. Now, that doesn't give us any overlap. You know, if you think about the way this is going to work, if we have two rooms that are next to each other, there isn't any overlap here at all. There's just an infinitely thin line. And I don't know, to make it easier on our collision detection math, I don't know if we want to do something where we would actually make it, you know, a little more forgiving than that. Right? Something where we're going to allow you to make the rooms, you know, the rooms would have a little bit of overlap there so that it was easier to make that transition on the math. But for now, we'll just start out with making them exactly a but, and then we'll look at that math later on when we're being a little bit more robust about things and thinking them through a little bit better. So that makes that. And now, in theory, we actually should see some giant rectangles if we didn't mess anything up. Hey, look, we do. Of course, it makes it hard to see anything else, but that is sort of what we wanted to see. And they look like they are maybe not quite in the right place, though, on the top. Oh, but that may just be because of the Z. I'm not entirely sure. Let's hop up to the next level and see if that's in a more sane spot. And it does look like it's in a pretty sane spot, actually. Now, the question would be what happens here. I'm not sure if I'm actually colliding with that entity. What is actually happening there? Like, why can't I go through there? Does anyone know? I have no idea. I'm interested to know. Let's take a quick look. I want to know if I'm actually colliding with that, because we didn't set its collides to be true, right? So in theory, that should not be the case, but I want to see if that's actually what's happening there, or if we had some bug from before that we weren't handling. So what I did is I hopped up to the next level there, like so, and I tried to go through here, and I could go through. So it seems like we're collision detecting against those entities, even though collides was not set, which suggests to me that we have a bug in there, which is that collides is not actually being checked properly, and so I would like to see why that is. Let's double check to make sure. Yeah, we're not setting it because there's standard room and just traversable is being set. I didn't do something stupid, did I? Like make traversable be the same value? Why did I set that? Why am I setting these that way? We don't need to set those to go up by powers 2. But yet, even so, it doesn't matter. We weren't overwriting this or anything. And so, as far as I can tell, that's just a straight up bug. So let's see why we're actually colliding against those standard rooms. It doesn't seem to make much sense to me. So let's see, were we checking the collides flag here? So we're not even checking the collides flag. We don't even check that flag anymore. We were just full on ignoring that flag entirely. And so when we call can collide, I strongly suspect that what we probably should have been doing here is saying something like, you know, if A, something like this, right? If A collides and B collides, then we can actually do this determination, right? Otherwise, we just assume that they can't collide. Because we really don't want anyone colliding with those things. That's not good. So that's fine. There we go. So here we are. Oh, I fell through the stairwell. Whoops. So there we go. Much better. Now, it's going to be impossible to see So what I would like to do is I'd like to make something that allows it a little bit so that we can see our regions a little bit better. And so what I'm going to do is just kind of make a real simple modification to our push rect call as soon as the 5-minute warning subsides. I'm going to make a little modification to our push rect call, and that push rect call is going to essentially do a series of push rects. So like push rect outline, something like that. And what that's going to do is that's just going to do a push piece for each of the four lines of rectangle. It's going to push like 4 separate rectangles, basically, so that we can see an outline of the region instead of this big solid region that obscures everything that we're trying to look at. And again, since we don't really have a renderer yet, this would be the kind of thing the renderer would take care of it for us, but until we get there, we've got to make do with what we have. So it looks to me like the way this is working is it just pushes the location of the thing and then an offset that it's going to spread out from. And so in order to make this work, what I would want to do is I'd want to do 2 batches, top and bottom, right? And left and right. The top and bottom are going to be wherever I was, the offset I want to basically move over by whatever, I want to basically move up and down by that dim, however big the rectangle was, right? I'll draw this out for you for those of you who don't write this kind of code very often. Grab my color back. So what I want to do here is I've got a rectangle, and I want to make rectangles that go around it like this. So I want to make like a rectangle here, right? And a rectangle here to start with, like so. And so I've got this, and I've got the dimension. So what I want to do is I want to move up to where the rectangle was, its dimension, right? Its dimension y. So this is the dimension in y. Well, it's half the dimension in y, right? I want to go half the dimension in y up, and I want to go out to along the dimension x, back and forward. So its dimension in x is going to be the same, right? The thing that I draw as dimension x is going to be the same. Its dimension y is going to be however thick I want that line to be, and its position is going to be whatever position the rectangle is in minus that dimension y, right? I'm just constructing that case. So what I want to do is I want to, again, take that offset. I want to move it by whatever the dimension is in y that I've been told to draw. And then instead of the dimension that I was going to draw, I want to take the dimension in x, leave that the same, and then do like a thickness parameter, right? And for the thickness parameter, I don't know what this should actually be. It's a good question. The dimension, I don't know that the dimension, what is the dimension, since this is all really ad hoc, we've never defined like what is the dimension even in when it draws the rectangle. I'm not sure. And so we kind of have to see, is that in pixels? It is in pixels. I'm sorry, it is not in pixels, it's in meters. So we want something very thin, right? We want not very many meters at all. We want like a centimeter, let's say, or a decameter. I don't know exactly how many, but let's say a centimeter for now is how thick that's going to be. And again, this is just going to be something that we do for both directions. So we want the top and the bottom, and those are exactly the same, just offset, the exact same kind of rectangle. And then we want to do the same thing again, but this time we want to do it with the x, right? Instead of the y, to make the left and right side. So this time we're going to have that y dimension becomes the thickness for us, right? And so that's all I want to do there. And now when we do push rect, we can also do outlines of rectangles, and that'll make it easier to see that stuff. So let's see if that worked at all. Right, we're kind of running out of time here. That did not. I do not see any rectangles. Oh, because they're too thin, it looks like. Well, let's take a look. Let's make that a little thicker. Push rect outline, like so. Just want to make sure. It also is offset. When I do a push piece, offset is multiplied meters per pixels in there, right? Yeah, it is. So in theory, that should be okay. So I'm just going to go ahead and make thickness a little thicker. I just want to see what happens there. All right, so there's And we're still a little buggy here because that's just drawing one line there. That doesn't make any sense. So let me double check what I have done incorrectly, because I have done something incorrectly. I can tell you that right now. Let's see. So we've got the thickness. We have the dimension in x. We are drawing. So I'm not sure why we're not seeing more of that show up. We're only seeing our left and, well, I guess just our left would show up. We're not ever even seeing any of these show up at all, which is kind of a little bit odd, I would say. So I'm not sure why that actually is the case. And our Q&A is supposed to begin now. So I don't know. Can we debug this in just a few seconds? I'm not sure. But maybe we'll just take a quick look and see. Because like I said, I don't like to really leave bugs till the next day if I can avoid it. Unfortunately, when you're only programming for an hour on stream, it can be kind of tough to actually make sure that you get everything in that you wanted. So push rect outline, here we go. Right? Let's see what we end up with here in terms of our pieces. So here's our piece group, right? And there's our pieces. So we're going to go through and push these. We push on a piece, a piece, a piece, a piece. So we do have 4 pieces that got pushed. And let's see what they are. So we have 2 of them. We've got one with that y offset, one with this y offset. We have, now is the offset, we have to make sure that the offset's actually still in meters. We want to make sure that the offset is not getting multiplied in some weird way, I suppose. But it's getting multiplied up in here, so that should be fine. Right? Is there something? Let me double check something. When we actually draw our pieces, what's the definition for the rectangle? Let's go take a look. Because I believe we said before that it was all janky. Remember? I think we talked about this before. So when we draw a rectangle, we do the center minus the half dim. I did forget to multiply the dim by half, so there is that. I don't know if that's in the entirety of our problem, though. But let's see, center minus half dim, center plus half dim. The center is what I think it should be, the entity ground point. It does look good. But I did forget to multiply. I said that it was half, but then I didn't actually do half. So we should actually fix that like so. But I don't know that that would account for the entirety of our problem, unfortunately. So let's go ahead and keep going here. Let's run that and recompile. So there we go. Is that the entirety of our problem? That was the entirety of our problem. All right, so that wasn't so hard to debug. There we go. It does fit the room nicely, so that's good. And we can go ahead and go up here. The top one's drawn wrong because it's not using the Z fudge. But when we go upstairs, it should be drawn right. There it is. And we can go through and into the next room. So now we've got those boundaries in our room set up. So that sets us up for tomorrow, doing what I said we were going to do, where we can actually now treat those as in-out. And that'll set us up pretty good for creating some multi-stage rooms. And so maybe that's, if we have time tomorrow to do that, we'll do that. If we don't, that'll be our Monday thing as well. All right, so now we can go and actually start things up. Let me get the Q&A going here. Let's see here. How do I start the Q&A? Q&A. There we go. The Q&A has been started. So, yeah, if you could please keep your questions and stuff that we... Well, you know what? I'm suspecting that if it's been relatively quiet today, I see someone saying, "Where are the trolls today?" I'm guessing that the questions will be pretty reasonable today, as opposed to days when sometimes it's a madhouse. But yeah, prefix your questions with Q:, if you can. Try to keep them on topic, and I will answer on-topic questions, obviously preferentially. So anytime I see an on-topic question, it takes priority over anything that might be off-topic. Let's see. All Let's see. So I don't see any particularly on-topic questions. So I'm going to answer some off-topic questions until until we get some on-topic ones. So what setup do I use for debugging on Linux? Unfortunately, the answer is printf. Linux debuggers don't actually work at all, in my experience. Especially not on laptops if you have Optimus, which all dev laptops do. I mean, honestly, I debug with printf. I use Qt Creator to some extent, but it can't even really inspect variables. It doesn't work properly most of the time. And even GDB doesn't work a lot of the time. It's debugging on Linux is a very sad and very unfortunate experience. So I mostly just use my own debugging. You know, I do it old school style. Like, I mean, when I grew up programming without a debugger, and so I wing it. It's by far the worst thing about Linux right now is the debuggers are awful. And I think that's something that really could make a massive difference for developing on Linux is if someone came along and made an actual good debugger, but it hasn't happened yet. So hopefully it'll happen in the future because I like Linux, and I would like to see it have a good development environment, and right now it does not have that. It might have that for other languages, like maybe the Java debugger, let's say, is good, you know, if you run Eclipse or something. I don't know. But the C++ debugging is real bad. And especially C++ and OpenGL Optimus is really bad. Let's see. Can you upload the video somewhere else? YouTube is blocked in China. I would like to watch from the beginning. So it's on my list of things to do. I just haven't gotten around to that yet. Basically, there really isn't anywhere else I can put the videos that would allow as much data as we have. But I was going to try to set up a BitTorrent sync that people could, like, you know, get on or whatever. So it is on my list of things to do, but I have not had a chance to do it yet. I'm sorry to hear that it is blocked in your country, and I would like to fix that eventually, but I just haven't had time to really figure out how to do that. Let's see. When doing the vertical movement, would it be reasonable to take two measurements, one at the current position, then one at final move position, and average the movement? I'm not sure what you mean by average the movement. I'm not sure I totally understand the question. I suspect the answer is no. It doesn't sound reasonable what you're saying, but I'm not sure I understand exactly what you're saying. So maybe that you are saying something that I would think was reasonable. And my answer to your question would be yes, it is reasonable to do. But I don't know. My gut reaction is no if I'm interpreting it correctly. Are walls going to be entities or just byproducts of subtracting of the room volume? We'll have the freedom to do both. So I suspect which one we do will depend on the type of room. Forests will probably be like entities for the trees because they'll form a very irregular border that we probably want to capture with entities. But like dungeon rooms, maybe will just be cut out. I don't know. LLDB works better than GDB if you can deal with the command line interface. Well, you know, if once you're on a command line for debugging, it's so slow that I'm usually much faster with printf than I am with a command line debugger. Because the only benefit that I really get out of a debugger is fast visualization of values. And that is exactly the thing that GDB and LLDB don't do well, right? They're really bad at giving you a good snapshot, a good visual snapshot of what everything's doing in your code. So I suspect that like I'd just probably keep printf in. You know what I'm saying? D. Johnstone 8. Should you have been able to jump up to a level above the player now that you have a 0.9 value for the space Z volume? Well, you should be able to answer that question. But just in case, you cannot. The reason that it doesn't matter what we set that value to is because we haven't done the collision detection for inboxes yet. So they are literally non-participatory, right? They don't, we just drew, all we did was add them and draw them. Tomorrow will be the time when we add them to the collision loop, and then if we can jump up, it's a bug. But right now, not a bug. Will the entities not at the player's Z level always be at the same alpha transparency, or will they be slightly less visible to show that they are on a different Z level? My guess, well, we have a to-do, right, which is probably the very next one after all this stuff is working to our satisfaction, is how is this rendered? And my suspicion is what we'll basically do is anything that's on the current level, if you're standing on the ground, is probably solid. Anything below you is solid. And everything above you is invisible. When you start to walk up a ramp, we'll probably move the camera up and fade in the top level or something. That's my guess. But that's the kind of thing that we're going to want to play around with. Like I said, I've never written a 2D game before. Every time I've even made like, I guess I did do one 2D game for the Game Jam. But all the rest of my Game Jam games were all 3D even. And so anything that I've ever coded has always been in 3D for the most part. And so I don't have a lot of strong opinions about how I want to do 2D things. So it's very exploratory for me. And I'm going through and saying, all right, what do I like about this? What do I not like? You know. So that's my gut feeling about how I'm going to do it. But we'll have to see when we actually do it, what we like, what we don't like. And maybe we'll have some thoughts about how we want it to work. I don't know. Why should anyone trust you to annotate a game when you have no published success preparing a full-fledged commercial game? Whoa, that's them's fighting words. I probably have code in more published commercial games than almost anyone I know besides maybe Jeff. So I don't know what you mean by that. If you're talking about the fact that I don't design games, that's true. But this isn't a game design course. This is a game programming course. So yeah, I mean, my code runs in a lot of games, certainly in the thousands, I would say at this point, between Granny and Bink 2, yeah, in the thousands. If you were a software programmer, how many apps could you have done in the same amount of time you have put into this? Of Handmade Hero? Well, you know, we haven't put that much time in, so 80 hours? 80 hours isn't that much. It depends on what you mean by app, right? Like, you know, and it depends on what quality level you're talking about, right? I mean, are you talking about slapping together some little thing that shows your Twitter feed, and you're just gonna like, call some prefab library code to put it up there or whatever? You could probably kick out a lot of those, right? Because they're not really doing anything, and they're kind of slow and bulky and whatever, right? But if you're talking about making something really good, you know, or you're talking about like a cool paint package or something, well, we probably wouldn't have gotten very far in that, you know. So it's hard to say. Hard to say. Will there be water, and how would it affect movement? So I think we probably should have some water, maybe. I don't know how it would affect movement because I don't super love swimming in games, so I don't know if I'd be inclined to add water, but it's worth noting I hadn't been thinking about water. I'd been thinking of the game as mostly like maybe it has some impassable water, like the water is just something you can't go across. So it's just another type of wall that looks prettier, right? That's how I had been thinking about water. But thinking about it more carefully, it is true that now that we're going with this sort of in and out box thing, we could define some of these boxes to be water, in which case you would like sink in them, and you could swim. I don't know. It's a good question. I'm not sure about the water situation. So maybe I want to add that to the to-do list. I'm going to add that to the to-do list because I hadn't thought about it, but we've kind of added something now where, where we have water in here. Let's see here. Water that you can swim in, maybe with currents too, that kind of pull you along. I don't know. It could be interesting. Could be interesting. Does the system used for the ground now make it harder to have things like moving platforms the player can stand on? I don't think so, because that would probably just be a moving entity. And so, if we wanted to do that, I'll add that as well while we're, since I already have it up. Moving platforms the player can stand on. We'll add that in there just as a thing when we do our collision detector as a good test of the collision system. I don't know how much of that I want to actually have in the game, but we could totally just show how to do it, right? Because our engine should support it, hopefully. Was the use of calculus involved in your programming? Actually, the use of calculus happened on the stream, in fact. If you would like to see calculus used in programming, you can actually go to the video archive and you can go back to the day called Equations of Motion, and you can actually see us do a bunch of calculus on there. And I'm not very good at calculus, so it's not going to be very good calculus, but here it is, day 43, the Equations of Motion. That is calculus going on right there, I believe. For this scheme, will the room geometries need to overlap in order to move between rooms, or can they just abut? That's what I was wondering too. They should technically just be able to abut and it'll be fine. But it depends on exactly how we write the wall intersection code to handle them. And so it may be that to make our lives easier, mathematically speaking, so that we can be sloppier in that code, we may just want them to be slightly overlapping, right? And so I don't know the answer to your question yet. We shall see. We shall see. Can you illustrate how they do the level editor's world layouts in modern engines now? Not really, because honestly, the very latest ones I have no experience with. So like, for example, in like how does Frostbite currently do their level edit, or Snowdrop or whatever it's called? I don't really know. And those are the two most recent engines, right? Frostbite 3 or something like this. Snowdrop's very recent as well. Unreal and Unity are obviously pretty old at this point and presumably have a lot of legacy in how they define things. So I don't know how those guys necessarily do it. I can tell you that in the Witness, it's essentially a geometry instancing kind of a thing, where people make meshes in Maya or a 3D package basically, and then we basically have a world editing tool where you bring in those meshes in and you place them to construct the world, right? So there is no notion of solid space, there is no notion of constructed solid, it's just polygon soups that gets slammed together. And then the way that you determine where you can walk is by having essentially meshes that are marked as walkable, and those are things you're allowed to move along. That's how it's done. But I don't know how similar that is to some of the newer engines out there, because I have not worked with them directly. Are you going to use files to store levels? If so, will they be custom format? We probably will sort of end up storing levels when you save the game. And yes, it's all obviously custom format because we're not using any libraries, so I guess you mean would we store it in like XML? Like, no. We want something that's going to be fast. Would the combat algorithm in a 2D game differ from a 3D game? Well, it depends on what you mean by combat algorithm. You'd have to be more specific about what you're talking about. Some of it might be the same, some of it might be very different, depending on what algorithm and what combat mean to you in this case. Let's see. How can I work with other programmers when our coding styles clash? Well, I don't know. I mean, what do you mean by your coding styles clash? Are you talking about like they want everything to be super object-oriented and you want everything to be super C-style or something like this? If that's the case, I would say, yeah, it's probably going to be pretty rough. You'd probably try to divide things so that you carve off very specific separate chunks of the code and don't really work on the parts that the other person's working on. If you're just talking about like they don't like having lines be more than 80 characters and I do or something, then just like, you know, everyone just get over it, right? Just deal with it. It's not that big of a deal because it doesn't really affect things. So it depends what you mean by coding styles. It can be a big problem or it can be not that big of a problem. Should there be walls around stairwells now, or will we still just use the collision rules from before? I don't know what we'll do exactly, but we won't have to add walls around stairwells. We'll just have stairwells be in boxes, essentially, probably that do a little bit better collision detection than regular boxes to account for the ramp area. Are you going to procedurally build levels or predefined levels? They're procedurally built. The whole game will be procedural for the most part, except for the art, which is obviously hand-drawn. Will we see stuff like light sources, ray tracing, surface mapping, etc. at some point in the stream? You're going to have to be more specific about what surface mapping means. That's a pretty ambiguous term. Light sources, definitely yes. Ray tracing, it depends on what you mean by that. If you're talking about runtime sparse voxel octree tracing or runtime KD tree tracing, no, probably not. If you're talking about ray tracing for other reasons, possibly. Have we started doing collision detection and handling? Yeah, that's how our guy runs into the trees right now. I don't understand the question. Yes. We've done a bunch of work on collision detection. We have not tried to write the final collision detector yet, but we have one in there that's running at the moment. What do you think about storing game data in code? I think it's fine. There are some obvious things you have to be aware of if you do it. Obviously, it can't be paged in very efficiently, so you can't store very much data in code. Like, I wouldn't recommend storing a lot of data in code. It is harder to deal with edits when the data lives in the code if you want to have GUI editing of that data. You can still do it, and I have done it. What you do is you put the code in its own C file, and you have the GUI editor rewrite the C file, and it works pretty well, but it'll also often end up being more trouble than it's worth. So it's, you know, it's 6 to 1/2 dozen of the other. I don't have strong feelings about it other than I would say know the advantages and disadvantages before you go that route. Proton Gaming. So will you continue complaining about Windows while making money programming with it and Visual Studio? Yes, of course. I'm not sure I understand the nature of the question per se. I guess what I would say is it's sort of an unfortunate mental trap that people fall into, that they believe that somehow complaining about something is like problematic, and that if you use something that you shouldn't be complaining about it. But the opposite is actually true, right? One of the reasons that Windows is getting worse is because the people who are, in a position to do something about it aren't complaining about it enough, right? They're not seeing the negatives in the thing that they're doing. And really, seeing the negatives in things is what makes someone a good engineer most of the time. Seeing the positives is almost useless in engineering, right? Like seeing whether the thing you made is really good doesn't help you, because all that tells you is what you've already accomplished. But what you've already accomplished is not actionable. I can't do anything about the stuff that's already done, right? It's done. It is what it is. So what I need to be able to see is I need to be able to see the problems. And there definitely is this sort of, there are really I guess there are probably two mentalities. I think both are very harmful for the improvement of software. One is the one you're evincing with the question, which is, suggesting that maybe the fact that you make money by working on a platform means you shouldn't be complaining about it. Doesn't make any sense. The platform that you are making money on is the one you should be complaining about the loudest, because that's the one that's your livelihood. You should care the most about the platform that you're making the money on, and you should be as upset as you could possibly be about problems with that platform, because that is the risk, the real risk to you, right? In some sense, it's no skin off my back if Linux never gets any better, right? I don't make any money. Well, I mean, maybe I make a little bit of money off selling things on Linux. I guess at RAD, maybe we sold some Linux licenses, right? So I didn't, maybe I had a little bit of skin in that game at one point. But I have very little skin in that game right now, right? And so it makes very little sense for me to spend a lot of time complaining about things that are wrong with Linux and hoping that people will listen and fix them, or to try and garner momentum around changing the prevailing attitudes about something that Linux is doing. It doesn't make sense for me to spend a lot of time doing that, because at the end of the day, I don't have a lot of skin in that game. Windows, I have a ton of skin in that game. That's where people buy games. And so the thing that I need to complain about the loudest, and what everyone should complain about the loudest, is the things that Windows is doing very poorly. And it's increasingly doing more and more things poorly, right? And so this notion that somehow you should be quiet about it because you are using it, it doesn't really make any sense. And I don't want to be too dismissive of your question, but honestly, it's sort of the attitude behind the question is not only, I think, wrong-headed, but also somewhat harmful in terms of if you want to get quality software at the end of the day, right? And so the other one that I see happen a lot, which is problematic, is this sort of notion that if you're going to complain about something, you should be doing something to fix it. And that doesn't make any sense either, right? If someone is literally sitting around not writing any code ever, I totally understand, right? It's like if you're just sitting around all day and you don't write any code, you're browsing Facebook and you're doing whatever, right? Then yes, if you go and say, Git sucks, and someone says, well, why don't you go fix it? Totally makes sense, right? Makes perfect sense. You're not doing anything right now. Nobody needs to go read BuzzFeed's top 10 cutest cats or whatever, and that's what you were going to do. So why don't you go take a look at GitHub and see if you can, not GitHub, Git, and see if you can fix it, right? Makes perfect sense. On the other hand, if you're already someone who's working on a lot of code, trying to make better software, trying to do useful stuff, and you complain about something, it doesn't make any sense to tell that person, why don't they go fix it? It's like, it can't be that person's job to fix everything, right? They can't be expected to go fix everything. Somebody is working on Git, and those people should pay attention to the complaints that people have about Git, not tell them that they shouldn't be complaining about it, right? Complaints are valuable. They are the most valuable thing that you have in software. They tell you what's broken. And the concept that you would want people not to voice those concerns simply because they don't have time to go fix whatever the thing is they're complaining about makes no sense. That works for nobody. All that does is it lets a bunch of people go around feeling better about themselves. And if we all want to have a little kindergarten where we pat ourselves on the back and we feel real good about ourselves at the end of the day, good job, Windows, you did great with 8.1. If that's the world you want to live in, I understand, okay, right? I understand why we would want to stop complaining. But if the world you actually want to see is one where the software isn't awful, then the complaints are, in some sense, the price we have to pay is feeling a little bit bad about what we did because it was lousy. That's important, right? We have to do that. That feeling that we didn't do a good job is important to make us do a better job next time. And it happens even in the small. Like on Handmade Hero, I don't want to sit around telling myself I did a good job on this collision detector. This isn't a good collision detector. We have a lot of work to do on this, and we should feel that way, right? And until we get it toward, we can't see any more serious defects, we shouldn't be stopping working on it, and we shouldn't be feeling like we did some kind of great job, right? That's not the way things work, in my opinion. So with that, I think that's probably a good thing to end the topic on, if that makes sense. So yeah. I'll see if there's any last minute ones. Let's see. I think there doesn't seem to be anything left. Can you rename the stream to Casey's Little Kindergarten? No, because I'm not going to tell everyone that it was a great job and we should feel great about ourselves. So it probably wouldn't be good to call it Casey's Little Kindergarten. But there could be a stream where that's the case. But yeah. So let's see. One day you said you lost hope in Microsoft, but now you complain so they can fix it. Well, no, that's not exactly what I said, but yes, that's true. I don't have any hope in Microsoft. I don't think they're actually going to be able to fix. I don't think they're listening. Is basically what I think, right? But that doesn't mean I'm not still going to try, right? Like that doesn't mean that I'm not going to say, here's all the stuff that's broken, in case you want to know, right? If anyone ever does start to listen, then they could fix it, right? But do I have hope that they're going to? No. But I don't have hope in a lot of things. Like there's a lot of things I don't have hope for, but I still, I'm not going to not still do the thing, right? Do I have hope that the world won't run out of water? Do I have, hope that we're going to have a sensible solution to our world's energy things? No. But I still recycle and I still walk to work. I still do the right thing, even though I'm not optimistic that it's going to have a happy ending, right? So I realize they're kind of trolling, and that's fine. People kind of have certain things, but your question actually does have a real answer, right? And so for people who are actually interested in the answer and not the trolling, it is true that just because you don't think that something will work out doesn't necessarily mean that you should stop taking the positive action, whatever that thing is, right? And so if you've just said, you know what, this software is not gonna, I've lost faith in this company. I don't think that they're ever going to be delivering something that we can use. That doesn't mean you shouldn't keep pointing it out. That doesn't mean that you shouldn't be there going, look, this stuff is still broken. Just so everyone knows, it is broken. Because you never do know, right? It could turn around. And the sad fact of the matter is we are stuck with the operating systems we are stuck with. It's Linux, Windows, and Mac right now, and there's not a lot on the horizon that's other than those things. And maybe the market share of those things will vary or whatever, but that's what we're stuck with right now. And so barring some fairly big changes in the market going forwards, we kind of have to still keep taking whatever positive action we can, because at the end of the day, we don't have a lot of options. Am I hopeful for the future? No. I mean, to be completely honest with you, no. I'm not hopeful that Microsoft will ever ship a good operating system again. I literally have almost no hope that they will do that. I have a desire for them to do that. I want them to do that. I want them to turn back into the company they were in 1990. But, do I think it's going to happen? No. I think there's almost no chance. But I'll keep on saying it. And you never know. Maybe someday they will. Hard to say. Was Git an example, or do you feel there are problems with it? Curious to hear. No, Git was just an example. I don't use Git, so I don't have any strong opinions. Like basically, source code control, I use my own. I'm sure I would have some issues with philosophically how Git does things maybe, but I don't know. I think maybe, I'm sure Git is probably good for what it does. A lot of people use it and seem to like it, so it must have a certain philosophy that works well for them. From what I've seen of it, it doesn't seem to be the way I would do things. But that's not really something I would necessarily complain about, because typically the things that bother me are when something isn't working properly or isn't made well, right? I don't tend to complain when something isn't the thing that I want it to be, right? Like I'm not going to go complain that a certain paint program doesn't allow me to do natural media painting if that's not what that paint program does, right? Like because it's different products in different spaces, and so yeah. So I don't have any problem with Git. I don't use it. I don't know. It could be great. It could be awful. I have no idea. I kind of randomly said it because it was kind of in my head that everyone always says switch to Git. They say it to John Blow all the time when he talks about source code control things. Switch to Git is that common thing that people say. And so I think I just said it because of the switch to Git thing. But the switch to Git thing is not really, has nothing to do with this. That's, yeah. So yeah, I have no complaints with Git. I don't even use it. I don't know if it's good or bad. And so, yeah, what can I say? So I think that's about it. I'm gonna call it there. Doesn't look like we didn't have too many on-topic questions today anyway, so I don't think we missed anything there. So I'm gonna go ahead and wrap things up. We will close it down, and here we go. Okay. So thank you everyone for joining me for another game. That's good. For another episode of Handmade Hero. It's been a pleasure coding with you as always. Yeah, we had pretty off-topic questions tonight. That's just how it goes sometimes, I guess. What are you going to do? If you don't have on-topic questions, you answer off-topic ones. But I'm pretty happy with the actual programming we did because basically, we didn't have a whole lot of time to do code, but we did sort of work through what I think is a reasonable solution in terms of how we're going to handle our moving, in terms of our definition of where the ground is and stuff like that. And so I'm pretty optimistic that that'll let things get cleaned up a little bit in the collision detector and let the notion of ground work a little bit better. I like when we make that kind of forward progress. So I'm pretty happy with that. And hopefully you'll be interested in coming back tomorrow. It'll be a morning stream tomorrow. 9 a.m. I believe is on the schedule. And so that will be when we'll actually go through and implement that in-box checking in the collision detector, which will allow us to kind of get that sort of ground testing that we wanted to have happen on the actual collision stuff. So right now all we're doing is we're adding those entities, but we haven't actually done the work to actually check against them. So that is what we'll be doing tomorrow. I hope you'll join me for that. If you want to follow along at home, you can always pre-order the game on handmadehero.org, and that gives you access to the source code. So you can download it, and you can follow along with everything we do, which is kind of a fun way to learn from the stream if you're interested in that. We also have a Patreon page to subscribe to if you're interested in supporting the series. We have a news and forum site where you can ask questions, and you can access resources that people have from the community put together, like ports to Linux and Mac, and an episode guide that's pretty awesome. We also have a tweet bot, newly updated to say whether it's Pacific Daylight Time or Pacific Standard Time. So it's even daylight savings time aware now. We don't know how long that'll last. It's kind of a, it was kind of a very quick project I hacked together. I don't claim it to be particularly well engineered, let's be honest with that. But anyway, if you do want to check out that tweet bot, it tweets the schedule at you. So if you want to follow along with the series, that's a good way to make sure you always know when it is. In addition to kind of you can subscribe on Twitch, but that tells you when I go live. It doesn't necessarily tell you when I'm going to go live, right, in the future. So that's pretty handy. So I hope you'll check those out, and I hope you'll join me tomorrow at 9 a.m. But either way, have a wonderful Friday, and I will see you guys on the next stream.